G'day there. If you're watching this video, you've probably found your way here through my GitHub repository for a Plasma Postprocessor for Fusion360 and the DDCSV CNC. So I thought I'd give you a quick run through on how to set it up and how to use it, including creating a basic part in Fusion360 so we can walk through the workflow. So the first thing you need to do is actually download the postprocessor file and install it on your machine. So the postprocessor is located on your machine, and if you have a Mac, it's installed into your library under the link that's shown on the GitHub page. And if you've got a Windows machine, it's a slightly different location, but the link's up there for you to follow. So once you've got that installed, let's move over to Fusion360, and we'll create a simple part that we can then run the post processor on and go and take that out to our Plasma. So let's start off with a sketch. Now the orientation of the sketch is quite important. You want to try and make sure that your z-axis comes straight out of the table. So for my machine, the x-axis is along the bottom, the y-axis is along the left of the table, and the z-axis points straight out. So we're going to use this front face and create a model or sketch on there. So I'm just going to create a simple washer, and we'll just draw our model on the origin for the time being. So a 10mm hole in the center, and let's make it 30mm in diameter. And let's finish that sketch. That's all we need to do there. We can zoom in on that. Let's give it some thickness using the press and pull tool. I'll give that a thickness of 6mm. I quite often use 6mm flat bar as stock on my machine, so this is a pretty normal thickness for me. Now, with our design done, we can now move to the manufacture aspect of Fusion360. Now, what it's going to ask us to do here, what we need to do is to put some setups in place and create some toolpaths that we can then export as Gcode to run in the CNC. So we're going to create a new setup, and we're actually going to create two setups. So we're going to create a plasma cutting path, but I also want to run through how to use the spot mark function so that it's easy for you to understand. So it's easier for me to make a video than it is for me to try and explain it in words, in text. So essentially the way that the spot mark works is it creates a small spot mark in the center of the hole, which then allows us to use that small mark, that divot if you like, as a center punch location that we can use on our drilling machine. And that's particularly useful on items that have very small holes, because plasma just doesn't cut very small holes that well. So we can pulse the plasma torch for a very small length of time, which will not cut all the way through, it'll just cut a little sort of crater in the top, but it'll be accurately located. We can use that as a center punch mark. So the way that we do this spot marking is that we must use a drilling operation. Plasma paths are generated on the edges of components, but we actually need to move our torch to the center, so a drilling operation is appropriate here. So to do that, we need to create a setup and choose a generic 3-axis machine for our setup. So you see here it has operation milling. Our work coordinate system, it's very important that this is the same for both operations, but also I find it's good to use the bottom left corner of the stock, because you can then zero your coordinate system on your plasma on your stock when you put it on the table. So you'll know that your part will be cut at some point to the right and above that. Select the items from our design. In this case it's the complete model. So I'm not going to put stock size in here, but you could put the actual stock size you're using. If you have a sheet and you want to gang up and cut a lot of these, you can put the sheet size in there and create multiple parts for you to cut. So post process, we'll just choose an arbitrary name. So this is our drill operation. That's it. So we've got that set up now for our drilling operation. So we then need to add an operation to that, the drill. So the tool can be any drill whatsoever. It doesn't really matter which drill we use. Just pick one that just comes up. The reason it's not important is because we're going to ignore all of the information from this drilling operation apart from the center point data for the hole. That's the only thing that we need to get out of this. We then use that information to generate our the rest of the operations. So we then need to select our holes that we're going to drill. So you can select as many holes as you need to at this point. So if you've got a part that's got multiple holes, you can select all of them and it will create the intermediate moves as well. We don't have to worry about any of these other settings, so we can just click on OK. Now here you can see we've basically got a part ready to go with the paths been created. So we can run a simulation and we can actually have a look at what this looks like. And quite simply, it's just a drill that goes in and out. So looks like we've chosen a spot face drill there. There's a spot face there. Next step is to create the cutting path. So again, it's another new setup, different machine this time. So the machine we're going to use this time is a cutting machine. There's only one here, the generic cutting machine, which applies to water jet and laser as well as plasma. So again, our coordinates need to be this bottom left here of the stock. We're going to select all of the model parts. Again, if you want to determine your stock size here, you can change it. And let's call this washer cut. Okay. Again, we add an operation. It's a cutting operation this time. And again, for tools, gives you an option of imperial or metric tools, and you have one each for your laser, plasma, or water jet. So for metric machine, so I'll choose the metric plasma cutter. Now, if you save these tools to your own local library, you can then edit them. So here you can see I've got two tools set up, one for spot drilling and one for plasma cutting, and that allows you to change things like kerf widths and clearance and stuff like that for different jobs. So you can have a multitude of different tools there with different setups for different materials or however you want to use them. So these feed presets, don't worry about these because we actually get to set all of the information related to feeds and positions as well, so standoff positions, cut positions, etc. in the post-processor. So again, we select our geometry. Now we're not going to select the center hole because we're going to use the spot mark operation on that, but we'll select this outer contour here. So you can see we've got an arrow, and that tells us which side of the contour we're cutting on and also in which direction. So that is set automatically. You can change it if it's incorrect, but 99% of the time it's absolutely fine. Interestingly, this direction, it gives a better quality cut because of the swirl direction if you go clockwise, so you always generally quite close on the outside and anti-clockwise on the inside of parts. So these heights here, we don't need to set these because we set these in the post-processing file. And some of the rest of this stuff here, the lead in, lead out, because it's positional data, we can set that here, and so it's important that you get that set up for your part. And also, if we just go back to the geometry, we can add tabs which can actually leave the inner part that we cut out still attached, so it won't cut through this section here. Now it's handy if you've got lots of parts on a single sheet, and it stops them partially falling through the table and sort of falling at an angle and getting the torch all tied up with it when it moves. So we can also set our entry positions here if that's important. Okay, so again we can run a simulation to see what it's going to do. Just make sure it moves as expected. And when we're happy with that, we can run a simulation for both operations, one after the other. Now we need to just choose the parent folder to be able to do that. And what you'll notice is it does the drilling operation first, followed by the cutting operation. And here you can see it's left our tab to keep our part that we're cutting out still attached to the rest of the sheet. And you can just bend that tab to break them out afterwards. So we're essentially ready now to create our Gcode using our Postprocessor. But one thing we need to do to get the Postprocessor to recognize the drilling op, what we have to do is have to change this particular setup here from a milling type operation to a cutting type operation. Now this is essentially fooling it into thinking that this is a plasma cutting operation. So the information that's passed to the Postprocessor is all of the information associated with drilling, but we're able to pull out just the hole center and just use that part in our Postprocessor. So if we've only got one of these operations selected, then it's only going to generate code for one operation. So again, we need to make sure that we select the parent folder and then go to our Postprocessor. So what you'll notice when you first open this is that you've got a generic list of postprocessors that are provided by Autodesk in Fusion360. So you've got things like Gerbil and Mac3, etc, etc. But what we need to do here is change our source to our personal post, which then looks at our local machine, and you'll see that the postprocessor that you earlier copied to your post folder will be in that drop down list, and you can select it. So program number, you can call this something appropriate. And then we can come down to our properties. Now if you keep this box ticked here, after it's generated the file, it will show you the file in your text editor on your local machine. So the properties basically from the top here down to the built-in properties here, all of these properties have been added into our Postprocessor, and so we're able to set things like the cut height, cut speed, pierce height, piercing speed, and we're able to tweak these and tailor these to suit our particular machine, material, etc. So change these to suit the job that you're doing, and then basically click OK, and we can then save our file, and it will automatically generate the Gcode. So what it's done is it's essentially taken our two operations and passed it through the Postprocessor file, which is a program itself. And you'll notice here, so setup 1, that's our spot marking setup, and then our initial drilling operation, which is now a spot marking operation. We've got a search where it searches down and probes the top of the stock to find out where the Z level of the top of the stock is. I have scratch start activated here, so this means it actually turns the torch on before it moves up to the pierce height. So scratch start machines require the torch to be touching the work there to actually start the arc to be generated. and then we're spot marking. So this is turning our torch on. We're then moving up to a pierce and then waiting for whatever the duration is before turning our torch off again. We then go into our second setup, which was for cutting, and we've got some intermediate moves here, so it moves into position over the first cut location. Again, we're probing to find the top of the workpiece, and it does that for every single arc start. Scratch start, same thing again, it's just starting a little bit earlier. Notice there's another torch on command here. This would be normally where it turns it on. And then we're working through our list of moves to cut the outer circle off. And then when we're finished, we're going to turn the torch off and retract the torch to a safe distance. So essentially this is created from the information that is contained within our model. Well, I hope you found that useful. You can shoot me an email or hit me up on Discourse if you need some help and want to reach out. Thank you.